show me which one you want to do the most. Okay, so I need to count. If you're a 1, raise your hand. Were you a 1? Okay, 4. If you're a 3, raise your hand. 1, 2, 3, 4, 5, 6. If you are a 4, raise your hand. Okay, if you are a 2, raise your hand. 2, 3, 4. I missed 1. 5. We're gonna have a 5. Okay, so we're gonna do 3.
Oh, 5.
Were you a 5?
Oh, no, I wasn't. I was
Okay. So for 3, we needed to find the solution of this. Remember, you have 3 ways to find solutions. Which of the 3 do we want to use? Okay. So if we're using elimination, which variable do we want to eliminate? The x's. Okay. Can we eliminate them right now?
Yes.
No. Oh. They don't have the same coefficient. Oh. So we need to make them have the same coefficient by multiplying this by what? 3 or negative 3, either one. So 3x minus 6y equals 15. And then how would we eliminate these? Adding or subtracting? Subtracting. So we're taking this and subtracting this. 3x minus 3x gives us 0. Y minus 6y is positive 7. 6 minus 15 is what? And then we don't really need the 0. So we end up with some fraction. Remember, that can happen. And then we need to put that back in. It could be either any of these. I'm going to put it back in here so I don't have to multiply it to anything. And how would I solve for x?
I is negative 9 on both sides. Negative 9 over 7.
So in your calculator, go ahead and do that. 6 plus 9 over 7.
Isn't it negative?
7.
So it was, but we added it, and now it's no longer.
Okay, yeah.
7 and 2 seconds.
Okay, those are the same thing. 15 over 7, or 7 and 2 seconds. Is that what you said? Okay, and then how would we solve for x here? Divide by 3, or because this is a fraction, I could multiply by 1/3. It'd be the same thing as dividing by 3. So x equals 15 over 21. Can this be simplified? Divide by 3, and we get 5. So our solution is 5/7, negative 9/7. Questions on that one? Make sure you have that written down and then pass your answer sheet back up. And then take out your solving inequality sheet. You could have just passed it up. So then, over here. A few of you finished that. You are going to finish it today. You will not have all class to do that. So you can go ahead and continue that. I need to give you one of those. And then when we come back from lunch, you'll have a little bit more time, and then we'll do some notes after that. You don't have this. I need to give that to you. Skylar. Ashley, go get it from your crate. I just put it in your crate. And today we're going to graph these inequalities, not just how we were doing the other day, but actually on a graph. So first let's go back to these the simpler ones. How would you read this? X is greater than 3. So that means what numbers could possibly be solutions to x is greater than 3? 4 and everything above it. I put 5. So would that be an open or a closed circle? Open. At 3. To the right or to the left? To the right. What about this one? How would we translate this? Okay, so we could say it 2 different ways. I heard x is less than or equal to -8. And then I also heard -8 is greater than or equal to x, which is also true. You don't need to write both. Pick one. Okay, so what solutions would work for this? I'm hearing
Is negative 9 and
is less than or equal to?
it's negative 9 and
It would have to be -9, -10. So remember, negatives work a little different. Would this be an open or a closed circle? Closed. At -8. And are we going to the right or to the left? To the left. Is everything less than or equal to? So you could rewrite this as x is less than or equal to -8, if that helps you. And that kind of goes along with, or that kind of helps you see our solutions a little better. It kind of helps you see that graph a little better. So those were like our more basic types of inequalities. And now we're going to get into our actual linear inequalities. So imagine slope-intercept form, but now with inequalities. So read these to yourself, these steps to yourself for 1 second. So that was a reminder, how do we graph lines? So we're graphing the lines the exact same way, and then there's a slight difference for when we actually graph these. For inequalities that have strictly a less than or greater than, we're going to use a dashed line. And then anything that has an equal to with it, so less than or equal to, greater than or equal to, we're going to use a solid line. So that means when we actually draw the line, it will either be a solid line like we normally draw lines, or it will be a dashed or a dotted line. It won't be complete. And then we're also going to be shading. So if we have an inequality that is greater than or equal to, we're going to shade above the line. But if we have something that's less than or equal to, we would shade below the line. So we're going to talk about what that looks like. Okay, so we're going to be doing shading and changing our line. So let's do this first before we even do the graph. The inequality says that y is, what is this symbol? Greater than or equal to so we will shade the graph. Will this be above or below if it's greater than? So above is always greater than. Below is always less than. And then because it's equal to, will this be a dashed or a solid line? Solid. So eventually these words will go away, but that's what you need to be thinking for every type of problem. What's the inequality say? What direction am I shading? What type of line will this have? Alright, so let's first graph the line. Where we start at? 6. And then our slope is negative 2/5. What directions would I go to get there? Down to right 5. As many times as possible. And what other directions could I go? Up to and left 5. As many times as possible. So when we graph our lines, we're going to do the solid or dashed first. We said this would be a solid line, so we're just going to draw this like we would any other normal line. And then shade it above. So you can do lines, you can actually color each square. I'm just going to do this. But you're shading it above that line. So now when we talk about solutions, our solutions could be anything in this shaded area. What questions do we have right now? Okay. Let's go on to number 2. For number 2, if this is not in slope-intercept form, you cannot fill this out because the direction of the sign may change. There is one thing that should never change. This won't magically become an equal to, so that will stay the same. So we know that this is going to be a dash or a dotted line. That part's not going to change. But to see, are we shading above? Will it still be greater than? We need to solve it. How would we solve this? Subtract 4x on both sides. have negative 3y is greater than negative 4x plus 12. I'm switching those so it's in slope-intercept form. And then, and what happens when we divide by a negative? The sign changes. So everything we just talked about with solving inequalities is still true. So now this is y is less than 4/3 x minus 4. So now we can say that this is less than. So what direction are we going to shade the graph in? Below. Okay. So let's graph this line. We're going to start at negative 4. We now have a positive slope, up 4 and right 3, as many times as possible. And then go down 4 and left 3 as many times as possible. Yes. Yes. And then because this is a dashed line, you're just really just going to draw dashes in between them so that it doesn't look like a full line. If you connect all the dots, you've now created a solid line. So you have to make sure there are spaces. So that really matters in this unit. What questions do we have on that one? Yes. So however you do it, as long as all of them aren't touching. Yes.
But there's still shade in the bottom half.
Oh yes, I just didn't do that. So that'd be below this. And if you are confused as to which way is above or below, draw arrows. So we know this needs to be below this line. So it would be in that direction. And we could have done that with the other one too. I'm going to go back and do that. If I drew arrows up because I know it's above this line, it would be in this area. I do want to do one more example with you, then I'm going to let you try some. This one has already been graphed for us, and we need to say what this inequality is. So we can find a couple things based on where it's shaded, what the type of line is, and then we can find the slope and y-intercept. So, is it shaded above this line or below it? So what does that mean?
Greater.
It's greater than. Now is it greater than or greater than or equal to?
Greater than.
How do we know that? Because the line is dashed. Okay. So now we know this has to be a y is greater than, and then we need our slope. So we need to find that. So I'm going to find 2 points that go through this exactly. You choose those 2 points. And what is that slope? -2. Our x still needs to go in there. And then what's our y-intercept? 8. Yeah. So you guys' graphs are a little small, and I apologize for that. And we'll get more practice with writing. I just wanted you to see this. Do we have questions on this example? Okay, I want you to go ahead and try the you try it example. And then I want you to move on to the practice work examples and see if you can do those. and then we'll come back and we'll talk about it. This is the you try it example. You had a positive slope. There should have been a dash or a dotted line. So I didn't dash mine because the dots and the dashes were kind of run together. So I just left mine dotted, but same thing. And then you should have shaded below the line. Questions on that one? I'm going to do 3 and 6, and then if we have questions on any others, we will probably go over it next class. So if we're remembering toy bucks, what type of line will this be? Horizontal. And then this is a less than, so will this be dashed or solid? Dashed. So at -4, I will have a dashed line. And then because it is less than, will I shade above or below this line? Below. So anytime you have a y is greater than or a y is less than, it will look very similar to this. So the above and below is really easy to tell which one it is. For 6, what type of line is this going to be? Vertical. So at -1, would this be a solid or a dashed line? Solid. And then you have to kind of think about this as if it were like the number line from before when we were solving inequalities. If x is greater than or equal to -1, what solutions would fit in this? Or what would be some solutions to this? 2 would work. So 2, 1, 0, all of these numbers on this side would work, so I would shade to the right. So anytime you have an x is greater than or x is less than, you're going to be shading either right or left instead of up or down. Did we have questions on 1, 2, 4, or 5? We are going to go over the 4 on the back next class and finish out those notes next class. So you can go grab your phones.